My name is Alyssa Bernstein. I'm a professor of social and political philosophy and ethics at Ohio University, and I'm director of the Institute for Applied and Professional Ethics. And the title of this panel discussion is Environmental Impacts of Deep Shale Horizontal Fracturing. And we have three distinguished guests. I'll introduce them in alphabetical order. Dr. Ryan Fote is an associate professor in the Department of Geography at Ohio University. He's also the director of the Scalia Lab for Atmospheric Analysis. He teaches many of the meteorology courses within the Department of Geography. A focus of his research is climate dynamics, in particular how components of the large-scale atmospheric circulation affect climate across the southern hemisphere, especially in Antarctica, or above Antarctica. His work incorporates climate models, observations, and station-based reconstructions of pressure variability to distinguish the contributions of natural variations and anthropogenic forcing in ongoing Antarctic climate change. Dr. Doug Green is an associate professor of geological sciences at Ohio University. He teaches a number of courses, including courses on the geodynamics of the Earth's interior, applied geophysics, environmental geology, and applied seismology. He's involved in fieldwork, theoretical work, and experimental investigations. His experimental work uses the Geology Department's station of the Ohio SEIS, S-E-I-S, earthquake monitoring network to characterize regional seismicity and seismic hazard. And Mr. Robert Wiley is a professional ecologist with a distinguished work and career history. With degrees in forestry, botany, geology, and landscape architecture, he has worked on a nationwide and international basis in ecological and engineering consulting services for public agencies, public utilities, and large and small private corporations for more than 40 years. He has specialized in environmental analysis, planning, water resources management, and ecosystem restoration. He's also a professional wetland scientist, a professional forester, a licensed landscape architect, and currently president of Good Ground LLC, a private ecological services corporation located in Athens County. He has worked for several years in assessing the landscape level effects of deep shale horizontal fracturing, which will be a subject of our discussion today. Between 2010 and 2013, he worked for the U.S. Army Corps of Engineers on an environmental impact assessment for removing water from the upper Missouri River to support oil and gas extraction in the Bakken Shale, that's B-A-K-K-E-N, shale formation of North Dakota and Montana. In February 2013, he was appointed to the Athens County Commissioner's Strategic Advisory Committee on deep shale drilling and hydraulic fracturing, and assisted until November of that year, in 2013, in researching the issues and preparing the final recommendations to the Athens County Commissioners. So I will start with a question for Doug. Please give us a brief summary of your research interests. Say a little more than I just did.
You said quite a bit. But I would say that one of the areas in geophysics that my students and I have been working on is Ohio seismicity, and in both the state and the surrounding regions, and looking at evidence in the seismic record for small events and what sort of patterns in time and space that they may be showing.
Thank you. Do you want to add to what I've said about your research interests?
Sure. So I'm interested in the climates of Antarctica and the southern hemisphere, and I'm particularly interested in unraveling the differences or separating out the influences from natural climate cycles, things that happen naturally or internally with the Earth system, and then human influences onto those, whether it be ozone depletion or greenhouse gas increases, and how those are changing the climate of Antarctica. And so that work would involve climate models to understand and attribute changes, but also looking at records of observed climate in Antarctica. Most of those records are very short. We only have data in Antarctica that starts around 1957 or so, and so we do statistical reconstructions of those observed data going back to around 1900 or so to get an idea more of the natural range of variability in the climate system there.
Thank you. And Rob, would you like to add to what I've said about you and your career?
Well, I suppose just to focus on what I did for Athens County most recently, that's the most germane, I think, to this discussion. I was appointed to the advisory committee to help evaluate what the total package of effects, the landscape level effects, might be from the occupation of Athens County by the deep shale fracturing industry. And we looked at, as much as we could, surface impacts and underground impacts from all of the associated activities, such as the trucking and the haulage of water and materials to the site, the overall landscape impacts of putting in all the drill pads, effects to the roads, effects to the local economy and the local sociology by bringing a lot of new people for a temporary period of time into the area. We worked with a committee of about 6 people, sometimes a few more, of county officials and local citizens, and we worked on this for about 6 months and ultimately put together a final report that we gave the commissioners, and that's about it, I think.
You'll have more opportunities later to add. Thank you. Brian, would you be able to tell us about some of the key findings about the latest report of the Intergovernmental Panel on Climate Change regarding climate disruption or climate change caused by humans and fossil fuel greenhouse gas emissions?
Sure. So the IPCC released their report, Working Group 1, in the end of 2013, followed the previous report that was in 2007. And the story was basically the same, but stronger, I think, in the 2013 report, that definitely the Earth is warming. We see a warming trend over the last century or longer. If we look on geological timescales, we see natural cycles of both carbon dioxide, methane, these sorts of things. But the recent values of these are far outside that range that we've seen on geological timescales. So things that are going back several hundreds of thousands of years, almost to a millennia, with these ice core records from Antarctica and Greenland. And using climate models, they were able to attribute the change, the warming, as not being able to be explained by natural causes, things internal to the Earth, whether it be changes in the sea surface temperatures in the tropics, or just natural processes on Earth with the volcanic eruptions or solar activity from the sun, but rather that to explain that warming trend, you needed to include those natural causes as well as human-introduced climate change, particularly emissions of greenhouse gases from fossil fuel burning. We saw that in the report that carbon dioxide in particular was the largest contributor to the changes in temperature across the globe, and the other greenhouse gases were basically being offset by some internal processes and cooling introduced by aerosols. But carbon dioxide was the biggest player in leading to the warming trends, and it was really strongly stated in that report that this warming trend could not be explained without carbon dioxide, and carbon dioxide increases in the atmosphere cannot be explained without including the human component.
Great, thanks. Can you say a little bit about exactly how your research is related to this?
Sure.
report?
So I study Antarctica, and we are interested in understanding the human footprint in Antarctica as well. We're not seeing, in my research, particularly strong influences from greenhouse gases like carbon dioxide, but we are seeing a strong influence of the ozone hole, which is also a chemically altered circulation in the atmosphere from human activity. CFCs were the primarily reason that we saw the ozone hole form over Antarctica, and it's leveled off now. It hasn't really grown in size too much, and it may actually be rebuilding and shrinking due to legislation and policy. The Montreal Protocol was key in regulating CFCs, and the ozone hole has been likely to repair because of that. And so we're seeing that kind of influence, particularly in Arctic climate. And so my work is directly relevant to see not only what kind of human signatures we're seeing on the climate variability of Antarctica, but also what policy can do to help to alter the emissions of chemicals that are harming the climate and changing the climate, and what those policies can do to actually help repair the climate.
Right, and we know that policies can also be damaging to the climate.
Sure.
Policies and economic practices, including fracking. Here's a quote from Louis Alstott, who is a former executive of the Mobil Corporation. Open quote, "There are already cases where the methane gas released by fracking operations has made it up into the atmosphere as well as into aquifers, drinking water sources. Sometimes it goes up through old well bores, sometimes through natural fissures in the rock. What we don't know is just how much gas is going to come up over time." I'm still quoting, "It's not just what's happening today. We're opening up channels for the gas to creep up to the surface and into the atmosphere. And methane is a much more potent greenhouse gas than carbon dioxide," close quote. You want to say something about the potency of methane, perhaps?
Yes, so methane is right now in concentrations in the atmosphere that are much lower than carbon dioxide. We measure carbon dioxide in parts per million. So for every there's around 400 parts per million of carbon dioxide in the current atmosphere. So for every 400 carbon dioxides, there's almost a million other gases in the atmosphere. So it's a small concentration, carbon dioxide. Methane is actually measured in parts per billion. So it's even smaller in concentration than carbon dioxide. But the concern about methane is that it's much more potent. That means it's actually more effective than carbon dioxide or nitrous oxide in trapping radiation that's left from Earth and trying to escape out to space. These are greenhouse gases. They are transparent basically to energy coming down from the sun, the shortwave radiation, the solar radiation, but they're very effective at absorbing radiation that's re-emitted by the Earth out into space. They basically act like a blanket, or they trap it in the atmosphere and send some of that energy back down to Earth's surface. Carbon dioxide does that, but methane is even more effective at doing that. It absorbs in more wavelengths, more frequencies in the atmosphere, and it also absorbs more efficiently compared to carbon dioxide. It's about 20 times or so more powerful at absorbing and radiating energy back down to the Earth's surface than carbon dioxide.
Over a period of 100 years.
That's right.
But if we consider a shorter period,
well,
20 years.
Yeah, methane has a shorter residence time in the atmosphere than carbon dioxide, and so you have to actually look on a comparable time scale to make those kinds of comparisons.
Doesn't it break down to carbon dioxide over time?
It can, yes,
Right.
absolutely.
Right.
So methane can break down to carbon dioxide, and also if we consider a shorter time period, methane is more than 20 times as potent as carbon dioxide as a greenhouse gas, meaning causing global warming.
Yes.
And on this topic, here's a quotation from Professor Anthony Ingraffia, Ingraffea, of Cornell University. His research concentrates on physical testing and computer simulation of complex fracturing processes. Open quote. "All the current consensus of climate science says that we only have about 20 to 30 years before we reach the warning zone, the dangerous zone, I think he means, of temperature rise that could lead to climate tipping points. And we cannot wait 20 to 30 years to just start decreasing CO2 equivalent emissions from fossil fuels. Over a 20-year period, the consensus impact factor for methane is about 80 times more powerful as a greenhouse gas than carbon dioxide. And that's a 20-year period instead of a century. And some peer-reviewed estimates say that it could be over 100 times more powerful as a greenhouse gas than carbon dioxide." And continuing to quote from Ingraffia, "There is no scientific justification for the use of a 100-year period by agencies evaluating greenhouse gas implications of increasing use of shale gas or methane from fracking." Would you like to comment on that?
Sure. So this idea of a tipping point that he brings up is this concept where we're moving to this point where there may be some irreversible changes, where we might be able to go back to the environment that we were in previously. Arctic sea ice, some scientists believe, may have already reached a tipping point where we may not be able to regrow summer sea ice in the Arctic Ocean because it's been melting very rapidly. We had major loss in the years 2007 and 2012, and it's not really rebounded since then. And with the warming across the planet being greater in the Arctic due to these feedbacks that exist between the ice and the atmosphere and the ocean, the Arctic sea ice is going to continue to decline and may not ever be able to regrow back into the summer to the levels that we had seen previously. Methane being this more potent greenhouse gas can also have these feedbacks because another source of methane besides hydraulic fracking is permafrost melting, and that releases more and more methane into the atmosphere too, and that happens as the Arctic warms. And so if sea ice is going away, there's more coastal erosion, more permafrost melting, more warming going on, that can lead to more and more methane into the atmosphere, and you continue to add more and more of this greenhouse gas, which is just going to accelerate the rate of warming that we're seeing across the planet.
Also, this same professor in Graphia makes a comparison between methane and coal as greenhouse, as sources of global warming. He says, when, open quote, when one looks at the coal-methane trade-off for electricity generation, the break-even leak rate, the leaking rate, over a 20-year period is less than 3%. Would you like, close quote, would you comment? Would you like to explain that?
To my knowledge, that you're basically comparing I think the radiative impacts these two gases can have, and the fact that methane is more potent, so you don't necessarily have to have as much of it as carbon dioxide in the atmosphere. We can change methane by as little as 3%, and that could have the same sort of radiative impacts on the climate as carbon dioxide increases are.
Thank you. So there's a connection between climate change and the fracking industry, and there's a connection between the fracking industry and earthquakes, is there not?
There is. Fracking as a tool in the hydrocarbon exploration industry has been around for decades.
If you are using the term fracking,
Hydraulic fracturing,
to refer,
even in vertical wells.
just vertical.
Right.
So, but today, a lot of environmentalists use the term fracking to refer to the modern technique of horizontal high-pressure hydraulic fracturing.
Which is an order of magnitude larger in operation.
And that's been used only in the last 15 years?
Right.
Okay.
That technology is very recent. But the byproduct of the current fracking operations is lots of waste fluids. And so one of the preferred, I guess, techniques for disposing of these waste is deep well injection, sort of out of sight, out of mind. And as long ago as the 60s, I believe, there have been examples of deep well injection triggering earthquakes.
Oh.
The Denver area experienced a number of earthquakes in '62 and '63, where they hadn't had such seismicity before, and somebody actually compared the rate of seismicity to the rate of deep well injection, and they correlated very well. So that was sort of the first well-documented case of injection-induced seismicity. So it can happen, and that's not the only one. There have been other examples as well. So yes, in terms of potential hazards, induced seismicity is always a possibility. Statistically, we've had a lot of earthquakes over time here in Ohio and the Midwest and the country in general, without any association with injection wells. We've got a lot of injection wells in the country with no associated seismicity. And then we have some injection wells that seem to be triggering seismicity. So overall, the correlation is not good. But yes, the potential is there.
Well, let me see. In a March 16th Columbus Dispatch article on the topic of earthquakes in relation to fracking, the article says, open quote, the county, and I guess I didn't write down which county, has one known fault line running through it in its southwest corner, according to a geologist with Ohio Division of Geological Survey. We know more about the surface of the moon than we do about the basement in Ohio, he said. There might be many other fault lines that won't reveal themselves until additional earthquakes are recorded. Following the 2011 earthquakes near Youngstown, Ohio, researchers found that a fracking waste injection well linked to them had been drilled on an ancient fault line. So I think they were talking about the county that Youngstown, Ohio is located in.
Mahoning, I think. Okay.
So according to this one, and according to a March 14th article in the Columbus Dispatch, scientists with Columbia University's Seismology Center say that fracking, with its high pressure, that means the horizontal high pressure hydraulic fracturing, the newer technique of fracturing, injecting liquids into deeply buried shale layers, is likely responsible for the earthquakes. These scientists at Columbia University dispute the Ohio Department of Natural Resources' denial of the significance of the recent seismic or earthquake activity and of its likely connections to fracking and or injection wells. And it's also interesting that in January 2011 and February 2012, researchers recorded more than 100 earthquakes that eventually were linked to the pumping of fracking waste deep underground into injection wells in the Youngstown area. And in January of 2012, the state of Ohio halted the disposal of fracking waste into injection wells within 5 miles of the Youngstown well. And so I was wondering whether your graduate students are, any of them investigating the environmental impacts of deep shale hydraulic fracturing.
I've had a couple of students looking at seismicity in Ohio, and one in particular looking at seismicity in the vicinity of operating injection wells over the same period of time that injections were occurring. And at least during the intervals of time for which we had data available in the seismic network, there were events, things that we saw in the record, which indicated they were due to earthquakes somewhere in the area. The locations never lined up with the wells within the time interval that we looked at, which I was a little surprised. I thought certainly we'd see something popping and snapping associated with these wells, and there was no obvious pattern related to the well. So I do have students looking at it. We're continuing to look at it. One of the problems is unless you have a large event like the Youngstown magnitude approximately 4, which some people felt even down here, the types of earthquakes that you're going to generate are generally pretty small in magnitude and very hard to see in the seismic record, what with noise due to traffic and other vibrations. So you're looking for a very small signal in the presence of ambient background noise. So it's very hard to pick out what's likely to be the most common occurrence of any seismicity associated with deep well injection, which would be really small magnitude events. They're just hard to see.
Which means that it's hard to gather the data on what is happening deep underground, and which means that this activity of fracturing to get methane and the activity of pumping frac wastes underground, deep underground, may be causing further cracking of the rocks.
Sure.
Without our knowing it.
Right, and provided that's all that's going on, I don't think it's an issue, because if these are so small the instruments can't detect them, then obviously they're not going to be have a negative impact to society. The concern is if you have a fault down there, and the Earth's crust is riddled with faults. I mean, there's lots of faults. Most of them we don't even see because they don't extend to the surface. And the faults that you need to be concerned about are those which have enough stress, tectonic or gravitational, that if they're allowed to slip, they could actually release a lot of energy of that stored stress as seismic waves. So if you want to think of a fault as a mousetrap, it's these that have stress on them, which a little fluid injected could, but like a set mousetrap, could set it off. Those are the ones that would be a problem. Most of the faults are like sprung traps. They formed long ago, stress regimes that don't even exist geologically. Now the rocks are still cracked. Those are less likely to cause a seismic event because they don't have the stress built into them. So most of the faults that are potentially impacted don't do anything when they get fluid in them. It's the ones which do have some stress, like the one in Mahoning County, the fluid injection apparently set it off.
Do scientists know about all the unsprung mousetraps?
No?
All of those faults that could, science don't
No,
know?
although usually a fault, if it has stress on it, has gone off before. So your best indicator of where those are, where have you had seismicity before? So the Nelsonville earthquake we had was on a known fault. Clearly that's a place that there is stress capable of shifting these large blocks of rock. Part of the reason for studying seismicity is to look, do you have clustered zones of seismicity independent of the injection wells? But that might tell you that you have a zone that's capable of slipping. And that is an important bit of background work to do.
So the earthquakes can not only, if they're large enough, disturb foundations of houses, they can also, is this correct, they can cause cracking up to the surface, which could release either methane or enable water to migrate, or toxic fracking fluids perhaps to migrate upward. Is that correct?
Anything is possible. That would be very unusual. That would be a very large event. Given the depths at which these earthquakes typically occur, the magnitude of the amount of energy they release, I would be very surprised to see them actually rupture the surface. But they certainly would rupture layers at depth.
At depth.
Can I ask two questions to him?
I was about to.
My first job when I got out of college was working for the Ohio Division of Reclamation and Mining.
Okay.
And we spent a lot of time assessing potential impacts from blasting.
Right.
Did surveys on foundations and that sort of thing, and then just monitored the outcomes.
Right.
How would you compare the kind of sense that we have of those kinds of surface shaking to what you might see in some of these fracking associated events, potentially
or
fracking?
induced earthquakes from injection.
Yeah.
I would say if you have a highway being constructed within a mile of your house, the blasting would be a significantly larger shaking than the typical earthquake that would probably be generated by an induction of fluid. The magnitude 4 earthquake that's pretty big. I don't know significant damage that occurred from it, but people would certainly notice it. I still think that a nearby blasting event near a strip mine or construction would still generate a higher level of vibration, and this is a concern.
It is a concern, and we did see
Right.
damages.
Right. And I guess this is a good time to point out that these operators who are managing the wells and the industry in general, they have financial reasons not to have accidents occur. They catastrophic spills, for example, induction of a big earthquake. This causes shutdown of operations. It causes potentially fines and penalties, and in the longer term, probably a higher level of regulation that they don't want. And so I think there's a built-in incentive in the industry to avoid those kinds of accidents, because that costs them money and that's their primary focus. So there is some incentive on the parts of these corporations to avoid doing that, and that's a good thing. I think of more concern is what is the acceptable allowed level of environmental impact from non-accidents but normal operations. So, the amount of leakage in a normal injection situation or in the fracking of the shale itself. In other words, what is being considered an acceptable level of impact, because that is guaranteed to happen in these operations. And we can talk about relatively low probability but sort of exciting things like earthquakes, but those may or may not happen. What will happen is what is going to be occurring when regular operations go on day in, day out. And I think those are not necessarily insignificant, and those are guaranteed to happen.
In that vein, I have one more question for you then.
Okay.
Earlier, we introduced the concept of a tipping point, where an event can build up, and you can suddenly have an effect from it that was not there during the accumulation of whatever the the pressure or stress was.
Right.
As we're filling injection wells, filling a potentially porous rock system, the Big Lime, for example,
Right.
here in Athens County.
Right.
Is there thinking about how the long term, we do this 50 years, let's say. We do this 10 years. Is there a meaningful way to assess whether or not there is some limit that would cause
I think,
a more noticeable event?
yeah, sure. And one of the big concerns with deep well injection is that these fluids migrate. Obviously, they migrate from the well because you keep putting more fluid in, and they don't migrate terribly rapidly. And there may be a long-term effect. You know, we may have one of these loaded faults some distance away, but it will take some time for the pressure front to diffuse out to reach that fault and trigger it. And that is something that you cannot monitor ahead of time. You have to wait. and
Well, I
see.
put this in the same context of 150 years ago when we began to seriously mine coal. We didn't anticipate the effects, and I've spent most of my career trying to fix those
Right.
that became apparent 50 or 100 years later.
Or I think even the idea that you're injecting into formations that we will never use in the future, so what difference does it make, that's a gross simplification of the argument. But, if I can finish, 30 years ago the industry was saying that about these gas shales. Can't get the gas out, they're not useful, never do them. And here we are, they're the focus of activity now. So never say never is you're right. And certainly in long-term effects, very hard to monitor on a short time scale what long-term effects are going to be.
In that connection, a concern is what our need for deep aquifers will be, because the U.S. has been suffering from severe drought, quite a high level of drought. I forget the technical term, but a very high level according to the U.S. Drought Monitor. And that's been continuing for several years, and apparently it's associated with climate change. And there's been a lot of drought also in Mexico, and I read that Mexico City has been drilling incredibly deep, I think a mile deep, to get to aquifers.
Right.
And so, although we may not think that we will need the groundwater that deep, the fresh groundwater, do these activities threaten the availability of drinking water?
The actual formations that they're injecting into are not saturated with fresh water. These are highly saline brine waters that are existing there. You'd be more likely to be using ocean water before you use those, just in terms of salinity. So,
What about closer to the surface?
closer to the surface. Now, if those get impacted, of course, then that is a concern, and this would be something I suppose Rob could speak on.
So, Rob, let's take it to Athens City and County. What is the source of our drinking water? And maybe you could talk about the wellheads and injection wells and their locations.
Our drinking water here entirely comes from the alluvial aquifer associated with the Hocking River. There are minor water sources throughout these hills, and they usually produce 1 to 5 gallons a minute. I used to live out in the countryside, and we had to make a decision on any given day whether or not we take a shower or wash clothes. So there's not really a highly productive aquifers out there other than the Hocking Aquifer itself. It supports much of Athens County, not all of it, some of Hocking, some of Meigs, and so it's a very sensitive and small aquifer, and things that could happen to affect that aquifer affect us all in a very big way.
So if our surface aquifers get polluted, we will need to dig deeper or dig elsewhere and bring water.
You would have to supply somewhere else. There's not a dig deeper option there.
Okay.
The material underneath doesn't hold much water. We have a channel in the Hocking River that was created by a river that cut down millions of years ago, used to flow north, got filled, now it flows south. We have a bedrock channel down there, though, that is only so deep. It's only about 60 or 80 feet deep. Correct me if I'm wrong on that.
No, that sounds right.
Yeah, and there's all the water is contained in a bit of material called alluvium material. It's made of rock and sand and silt that holds water that runs down off the hills and falls directly from rainfall. So that's a very sensitive aquifer.
Is the Ohio River a source of drinking
It
water?
is. It's not for much of Athens County. The Tupper's Plains system is located in the Ohio River, takes water directly from the river. By the way, it's already contaminated by the C8 problem from the industrial areas down in
DuPont?
Washington County. Yeah, I believe it was DuPont.
But the Ohio River supplies drinking water for millions of other people.
Oh my God, yes. You know, a couple of years ago we had the spill on the Kanawha River, which runs into the Ohio River, and it affected everybody clear to the Mississippi River before it was, you know, thoroughly polluted.
And there are currently, there's a proposal, I think it's still a permit proposal that has not yet been granted by the Ohio Department of Natural Resources. The permit is requested, if I recall correctly, by the Green Hunter Company in Texas.
I have nothing to do with it.
And I didn't look at you for
Different
that.
different Doug Green.
They are proposing, the company, which I'm pretty certain is that one, is proposing to transport toxic fracking waste, liquid waste, on barges across the Ohio River from Pennsylvania for purposes of disposal in injection wells in Ohio, including in Athens and Meigs County. The proposal is to build the barge dock in Meigs County. And so one of the concerns, is it not, is barge accidents and a spill into the Ohio River. How serious do you think that might be?
Depending on the sizes of the barges they're talking about, it could be very serious locally. The Ohio River flows in a massive amount of water, so likely with any barge spill, dilution would occur fairly quickly. It's still not a good idea, you know. And I want to mention one of the words you used. You said toxic. One of the problems with fracking waste is it is not characteristically identified as toxic under officially. And this is an important issue because it's not handled that way. It's not handled that way. You know, anything that's toxic under the RCRA laws or the CERCLA laws has a way of being handled, a way of being dealt with if a spill occurs, you know, so that first responders can deal with it. Well, if you have a substance that's identified characteristically without testing as being non-toxic, you really can't put an effective program together on how to deal with that.
So RCRA and CERCLA.
Resource Conservation and Recovery Act and the Comprehensive Environmental Liability, and my God, I've forgotten the rest of it.
That's pretty good, though.
Those two laws identify all chemicals that we use and define ways that we handle them in order to make them, you know, non-toxic within our environment.
But there's an exemption for...
There's an exemption that was put into the 2006 Energy Act, sometimes called the Cheney Act, or the Halliburton exemption, to say that the material that comes out of wells, whatever it is characteristically non-toxic. Now, this occurred before. This is not the first time. Back in the 60s, coal waste was identified as characteristically a non-toxic material, so the disposal and handling activities were made to be very cheap for the industry because you didn't have to consider those things. That's been reconsidered in the last decade. I'm not sure what the status of it is right now, but I know it's going back into a hazardous waste category.
So I'd like to quote a paragraph from the report you worked on as a member of the Strategic Advisory Committee for Athens County. Open quote, "Currently, the primary impact in Athens County from deep shale drilling in Ohio is the significant increase in out-of-state wastewater transported and injected into local Class II disposal wells. This brings issues of water contamination and road degradation, has negligible local economic benefit, and displaces the disposal capacity of local vertical drillers. This is the main foreseeable impact of deep shale drilling on our county for the near future." This is on the assumption that the fracking operations themselves
don't actually come here.
Don't actually come here, but we'll see. "Athens County limestone," I'm continuing to quote, "is highly permeable and considered well-suited for injection disposal of the frack waste, while our deep shale seems less productive for oil and gas than other areas of Ohio, which are considered to be the sweet spots for drilling." And there's some disagreement about that, but not a lot.
Well, there is, because we're talking about something that's deep underground. And, you know, although you can look at a map of the wells of Athens County, and it seems like, or at the wells of the state of Ohio, there are thousands of them, but it's still not enough information to be absolutely precise. They think now that the productive layers, given the economy that they're working in, because mining and drilling are all about economy. They're not about the product. If it's there and it's worth $1,000 a barrel, they'll get it. But if it's worth $10 a barrel, it's not there at all. So there's some down there. We don't know exactly what it is, whether that comes or not. As far as in talking to drillers around here, what we learned was that there is a very good limestone layer that is relatively porous and can be used in Athens County, and it's less deep here and perhaps more porous. Now this is I don't have personal experience with that, but that's what the drillers tell me.
Right.
So Class 2 injection wells, as I understand it, and correct me if I'm wrong, is a federal classification used to designate waste wells that can be used for non-hazardous materials. Isn't that correct?
I think we've covered that issue a little bit, haven't we? It's not hazardous material officially.
Officially. So shale gas extraction has been linked with water and air pollution and associated health effects. And the more common cause of water contamination, and I'm still quoting from the Strategic Advisory Committee report, is when well casings or containments fail due to poor material quality or improper installation. While rare, water contamination is a problem that can be catastrophic for those impacted by it. A rare but real risk related to well drilling and construction includes methane gas and vapor intrusion into homes and water wells. In all drilling and production activities of the oil and gas industry, ambient air emissions of hydrocarbons and other pollutants are present. The sources of these air pollutants can be from vehicle emissions, safety flares, gasoline or diesel-powered generators and pumps, and oil and gas separation and storage tanks. So there are various kinds of concerns. There's water pollution concerns, and there's also air quality concerns. And there's been some research linking air pollution from fracking operations with health effects for people in the vicinity. And I'm looking for the research that I have on these papers about it. Let's see. Here's a quote from an academic article in the journal Environmental Science and Technology published in March of 2014, that's this year. Open quote, dangerously high concentrations of air pollutants are threatening, this is a study done in Utah, so they say they're threatening rural Utah. Winter levels of volatile organic compounds released from oil and gas wells in Utah's Uinta Basin were, it says, equivalent to the annual volatile organic compounds emissions of a fleet of about 100 million automobiles. The pollutants include the carcinogens benzene and toluene.
Toluene.
Whatever. Toluene, and compounds that are precursors of ozone, which can cause respiratory problems. And a press release in March of this year about a study done at the University of Texas said that there are increased rates of childhood leukemia and childhood lymphoma in the vicinity of these operations. In April of this year, a Colorado study reported an association between density and proximity of natural gas wells within a 10-mile radius of maternal residence, the residence of mothers, where they live, and the prevalence of congenital heart defects and possibly neural tube defects. So these are serious health concerns.
The issue of leakage, I think, is a very relevant and pertinent one in that, for example, in oil wells, leakages are pretty easy to detect. I mean, when crude is spilling, it's pretty easy to observe, quantify, and hopefully recapture and try to do something about it. But the point is that it's easy to detect. I think with natural gas, leakage is very hard to estimate. This stuff comes out, it's invisible, unless you are monitoring very closely and throughout your entire operations. it's very difficult, I think, to get an accurate estimate of how much you're losing. And I think the industry, they'll say that they estimate their leakage at less than 1% of production. Sierra Club says 12% of production. So even if you went with 6% of production, is somewhere in between, that's a lot of leakage.
So one of the reasons for leakage, as I understand, is well failure, or failure of the well barrier and
Just
integrity.
Pipelines, wells, leakage through the subsurface potentially, but it's, who's going to measure this? Who's going to monitor it? Who's got that kind of money?
Well, there's been a study
You like that?
in the Journal of Marine and Petroleum Geology this year that measured the rates of well failure in Pennsylvania. It says they're more than 1 in 20, 6.5%. And this person I quoted earlier, the former president of Mobil, Louis Alstott, said the following on well integrity, open quote, "There are lots of good indications that plugging the well doesn't really work long term. And sooner or later, the steel casing there is going to rust out and the cement is going to crumble. Even if nothing comes up through the fissures in the rock layers above where it was fracked, those well bores will deteriorate over time. And there is at least one study showing that 100% of plugs installed in abandoned wells failed within 100 years, and many of them much sooner."
And that has occurred already, even before the shale gas boom, that waste injected down injection wells has shown up in old abandoned petroleum wells that perhaps people didn't know about, or they thought they were plugged, but the casings were bad. So there is a lot of connection in these old legacy wells between lower, deeper layers and surface ones. And that's always been a concern about deep well injection, and some states don't allow it at all.
That brings me to the fact that on the ballot this November 4th, first Tuesday of November, in Athens is a proposed ordinance. It'll be issue 7 on the ballot. And it will prohibit certain activities. It will be unlawful, if it's passed, for any corporation to engage in exploring or extracting shale gas or oil within the city of Athens, and unlawful to basically drill injection wells within the city of Athens. There's legalese here that I'm not going to read. But the bill is also a declaration of rights: right to potable water, right to healthy environment, right to be free from chemical trespass, right to a sustainable energy future, and right to self-government. So given that there are so many disadvantages and potential and actual current harms from the fracking activities and the injection well activities, the question arises who benefits and how many people benefit. In this report of the Strategic Advisory Committee that you worked on, Rob, it says that the economic benefits are to the injection well owners and to the Ohio Department of Natural Resources from their waste disposal tax. Now, those are benefits from injection wells. Benefits from the fracking operations would be profits for the corporations and pay for the workers engaged. And so there's been discussion, debate about how big are the benefits in terms of employment. And the advocates of fracking operations say we're going to bring jobs. And the critics say you bring people from elsewhere to take most of those jobs, and the other jobs don't last very long. And the influx of large numbers of workers from elsewhere has in many locales resulted in a lot of lawlessness. And the trucks, the high-intensity truck traffic has resulted in harm to the roads and a lot of noise. And there's been also illegal dumping of the toxic liquids, which is one of the problems associated with areas that are operating injection wells. Because in order for the risk to be minimized, the ideal has to be made real. In other words, everybody has to do exactly what they ought to do and not cut corners and not break any laws. But there has been a certain amount of law breaking, some of it prosecuted, in terms of transporters of the toxic waste illegally dumping it into waterways, even in Athens County. And I have a little bit of documentation about that somewhere here. And I want to mention the K&H injection well or wells in Athens County. This well is in Troy Township in Athens County. In fact, I believe there are now 6 injection wells operating in Athens County. At any rate, at least
2 proposed and 4 operating.
is that it? Okay, good.
I think that's right.
Thank you. And in the year last year, 2013, in Athens County, there were 29,367,000 gallons of frac waste injected into these wells. Throughout Ohio, it's been a total of, for that year, 2013, 16 million barrels. And half of it comes from outside of Ohio. So there are states where the fracking operations are happening, but they're not disposing of their waste within their state limits. And to my knowledge, that is true of Pennsylvania. Pennsylvania ships all of its frac waste over to Ohio. 7 counties in Ohio receive the most frac waste, and Athens County is one of them. And in Athens, in Troy Township, is an injection well called K&H. K&H Partners is the company. And in 2013, the K&H well received 23 million gallons of frac waste. And ODNR, Ohio Department of Natural Resources, received money for that, $91,900. And K&H has recently requested a permit for a second well, which would receive or may receive almost 3 times as much waste as the first one, which received 29 million gallons in 2013. So the total volume for the K&H1 and K&H2 injection wells would be close to 100 million gallons. And there have been criticisms made by local residents who are concerned about this, criticisms of the procedure by which the ODNR issued permits for these wells, and in particular the permit issued for the second one. They point out there was no geological analysis done, there was no seismic study done, there was no mapping of the aquifers, there was no verification that the injected liquids would be confined within a certain zone, and there was no monitoring and no disclosure of the contents or radioactivity levels of the liquid injected underground, and there was no monitoring of drinking water or groundwater after the injection to assess whether there had been contamination or migration of the wastewater. Which brings me again to the upcoming issue 7. And perhaps I'll ask you if you have any additional comments you'd like to make.
I've been wondering who was going to end up in a hot seat here.
Did you want to comment any further on this proposed ordinance, which would prohibit injection wells and fracking within Athens city limits?
Well, I'm not sure what question you asked me yet.
Well,
and commenting on it is potentially to be useful, and it's more of I think, a political statement than a meaningful.
I just wanted to see if you had anything in your mind.
Okay. I have a few things in there,
but okay. Then I will turn instead to you, Doug.
Okay.
Is the secrecy on the part of the oil and gas industry with regard to the ingredients of the fluids that they use when fracking, is that a problem for conducting research?
Well, lack of information is always a problem in conducting research. So, short answer is yes. And I think it's really unfortunate that the industry has sort of retrenched to that position, because it just adds to the suspicion you know, what are they doing and why aren't they telling us? And it's not, I think in the long term, it's going to be a detriment to the industry to have built up this wall of uncertainty as to what's in the fluid, you know, what are their flocculants, what are their fungicides, what are these things. So I understand why they do it, right? Because any information out there can be used against them in a civil court. And so they've circled the wagons. They're not going to release information that can be used against them. But I think it has really poisoned public perception of what they're doing. And I think in the end, that's going to be a problem for them.
And lastly, in view of all these problems with fossil fuels, what alternatives do you think would be good options, for example, especially in Athens County?
Yeah, I think for alternative energy sources for Athens County, I think the best option is solar. There, I think, are 2 companies in Athens currently that are
At least 2.
At least 2 that are providing solar energy alternatives for the residents. I know it's
Third Sun, SunPower, Dovetail, I think 3 at least.
Yeah. So it's a high startup cost to install these normally, but there's a big payoff with time, with the amount of energy that you're consuming, you know, per watt. So it's definitely, wind's not going to be an option for Athens. I don't think we don't have enough sustained wind here, but solar is probably the best alternative and very clean compared to any other alternatives out there.
Thank you all for taking part.
Thank you.
Thank you.
Thank you.